To go into section 2-3. We spent the last couple days working with parallel lines and making sure we knew what parallel lines were, being able to find transversals, doing all those different types of things. The next thing we're going to work on, the next section is section 2-3. There's going to be two parts to section 2-3 that we're going to talk about today. We're going to start out by introducing what the triangle sum theorem is. It becomes pretty self-explanatory, but that'll be the first thing that we do, and then we're going to work on solving different parts of a triangle using the triangle sum theorem. So that'll be the first thing that we're going to talk about today. And then the second part of today is we're going to talk about what we call the remote interior angles theorem. And we'll explain what all of these things mean kind of as we go along. With the ultimate goal of being able to take, the different types of problems that you're going to see today, whether they be the sum of the interior angles of a triangle like these, or they be remote interior angles. The whole goal today is to be able to solve either types of these problems for x with some level of not badity, I guess. So the triangle sum theorem. Triangle sum theorem says this. Okay, so in your notes, you should have triangle sum theorem. The triangle sum theorem says the sum of the interior angles of a triangle is 180 degrees. The triangle sum theorem says that the sum of the interior angles of a triangle is 180 degrees. So sum means to add. Interior means inside. Angles mean angles. Triangle means it's a three-sided figure in a closed plane. Okay, so if you have a triangle, and you all know what triangles look like, you know what the inside of a triangle is. In this case, in the drawing that I have up there, it's X, Y, and Z. They are on the inside of the triangle. Sum means to add. Therefore, if I would take x plus y plus z, they have to equal 180 degrees. Always. In a triangle, this is the case. Always. It never changes. For the rest of your lives, if you're looking at a triangle, the measure of all of the interior angles has to be 180 degrees. Okay? So x plus y plus z equals 180. So if we look at some just kind of basic examples, this first one, we're going to solve this first one for x. Well, the triangle sum theorem says that if I take 30 plus 70 plus x, that those three angles together have to add up to 180 degrees. And it doesn't matter what's written there. Okay? I could have smiley faces sitting there. They all have to add up to 180 degrees. Now we have to solve for x. So 30 plus 70 is 100. 100 plus x is equal to 180. Subtract 100 from both sides. You get x is equal to 80. So the measure of that angle, x, has to be 80 degrees. 80 plus 70 plus 30 adds up to 180. And again, the interior angles, no matter what's there, they add up to 180 degrees. Okay, so if we look at the next example, again, we've got this triangle sitting here. We've got two acute angles. The two angles that look like they're less than 90 degrees. They are 20 and 30. And we've got this third angle. It looks obtuse. Probably is. But we can find out what it is. X plus 20 plus 30 has to add up to 180 degrees. And I can put it in any order I want. I can go 20 plus x plus 30 equals 180. They say the same thing. I have a tendency to do it like this one, just because my numbers are together then. So we've got 20 plus 30 is 50. Subtract 50 from both sides. The measure of that angle is 130 degrees. And I didn't show the subtraction of 50. We've solved tons of equations in here. Shouldn't have to show you every single time what that looks like. Questions with those two so far? Okay. It can get a little bit more complicated, but it comes about remembering what definitions are. So again, we've got this triangle. I give you the 40, so we know we've got the 40. Do I give you another angle measure? Yeah. What's that box mean? 90. So 40 plus 90 plus x has to equal 180. Is that 130? Plus x equals 180, x equals 50. So there's the value of x. A little more complicated. I didn't give you that, but you guys know what that box means at this point in time. We've talked about it lots of times. It equals 90 degrees. Okay, well, does it matter if I change it up instead of have x, have 2x? No, not really. It becomes the same thing. What's this equation going to look like? I'm going to start with 2x. 2x plus what? 40 plus 50 equals 180. Combine like terms, 50 and 40 is 90. It doesn't live. We're good. It doesn't look like it is. This is probably a bad drawing. Bad drawings happen. So 2x equals 90. Divide by 2. X equals 45. And that's your solution. Again, doesn't look like that, but drawings can be misleading. That obviously doesn't appear to be a 90-degree angle. It's not, but whatever. It's the way I drew it. Still goes with the fact that the sum of the interior angles is 180 degrees. Okay, so let's get a little more complicated, but not bad. Go ahead and write the equation for that one and solve for x. Write the equation and solve. The sun's out. When did that happen? Has the sun been out all day? Has it been clear all day? Noon? What's that? Yeah. All right, I always start with where the variable's at. So I'm going to start with x plus 62. I've got a 40 there. What else do I have? 90. They have to be 180. Add all of those up. What is it? 192. 192. So you get x plus 192 equals 180. Subtract 192, you get x equals, and that's okay. It's just our x value. Plug the x value in, it still gives us a measure of 50 degrees. Okay. All right, go ahead and do that one. Find the value of x. Again, all I'm asking you is solve for x. 150. That's right. So far, so good? Mm-hmm. Any questions so far? So I got 5x plus 5 plus 80 plus 65 equals 180. Mm-hmm. Add the numbers together, you get 150. Subtract off 150 from both sides. Get 5x equals 30. Divide by 5, x equals 6. So the sum of the interior angles of a triangle is 180 degrees. Are we okay with those? Yeah, those aren't so bad, right? All right, the next theorem that we need to talk about is what we call the remote interior angles theorem. This is the second part, and this part is a little bit more confusing. So we've got the remote interior angles theorem. It's kind of the heading of it. We're going to have to get some definitions first. So, definition of remote interior angles. This drawing needs to be in your notes. Okay. Here's the definition of remote interior angles. Two angles that are inside the triangle and opposite the exterior angle are called remote interior angles. So that's the only part I want you to write so far, just the purple. Don't write the blue yet. Two angles that are inside the triangle and opposite the exterior angle are called remote interior angles. Give you a couple seconds to copy that part down, and then we're going to put a couple pieces on the drawing. So in the drawing, X and Y are on the inside, and Z is on the outside. So X and Y are on the interior, Z is on the exterior. Y and X are also the opposite sides of that exterior angle. The exterior angle is going to be the exterior angle that's furthest away from our two remote interior angles. So in this case, Z is that exterior angle. So that exterior angle is going to be drawn. The two angles inside the triangle that are furthest away from it, those are your remote interior angles. And here's what happens with those remote interior angles. The sum, and this is next thing for your notes, the sum of the two remote interior angles is equal to the exterior angle. The sum of the two remote interior angles is equal to its exterior angle. So in our drawing up there, Y plus X has to be Z. And we'll show you why this works here in just a second. The sum of the two remote interior angles is equal to the exterior angle. They don't add up to 180, they equal each other. And that's the theorem itself. The sum of the two remote interior angles is equal to the exterior angle. So x plus y is always going to equal z. So what do problems like these look like? And these types of problems look like this. X is our exterior angle. It's on the outside. 60 and 70 are the angles that are furthest from it. So this theorem says that 60 plus 70 has to equal x. 60 plus 70 is 130, so x is going to be 130. Okay. Now let's think about this just for a second. And why does that make sense? What's the measure of z? Could I find z if I asked you to? Okay, z would be 60 plus 70 plus z. The interior has to add up to 180, right? Okay, so that's 180 degrees. So that's 130. So that's z equals 50. So this is 50 degrees, right? What do these two angles have to add up to? Those two angles have to add up to 180 degrees. They form a straight line, right? That's why this theorem works. Okay, if we find that third interior angle and the sum of the interior angle, the adjacent one and that one, they form a straight line. So they have to add up to 180 degrees. So that's why this theorem works. And it's a pretty good theorem. Okay? So the sum of the remote interior angles is equal to the exterior angle. So in this one, facing a different direction, you can still see where the triangle is. It's still just giving you the remote interior angles. So the setup for this would be x plus 30 equals 100. Variable's in a different spot, but it still has to, the sum of those two inside ones still has to be the exterior angle. So you get x is equal to 70. And that's your solution. Inside plus inside equals outside. As long as the two are on the inside or the furthest away from the outside. Let's look at the next one. A little more complicated, but the theorem still holds. Theorem doesn't change. The math gets ugly sometimes. Setting them up never changes. The sum of the two remote interior angles is going to equal the exterior angle. So sum means to add. So x plus 43, that's the sum of the interior angles, sum of the remote interior angles. That has to equal 6x plus 4. By definition, that's how it works. Now we just have to solve. We got to get our numbers on one side and our variable on the other. So I'm going to subtract x. So that's 43 equals 5x plus 4. Ugly number, but that's okay. Subtract off 4. So 39 equals 5x, divide by 5. So it's an ugly number, 39/5, but that's okay. Fractions happen. There's nothing wrong with them. Not what we want. but it happens. Okay. And we can make it work if we have to. The sum of the remote interior angle is equal to the exterior angle. Go ahead and find the value for x. And this is the last one we're going to do. Go ahead and find the value of x that makes our remote interior angles theorem hold. So what does my theorem look like?
5x plus 7x plus 10.
5x plus 7x plus 10 equals 130. 5x plus 7x is 12x. I'm just going to subtract 10 from both sides. Equals 120. I skipped a step in there. Everybody see what I did?
Yeah.
I just subtracted the number to get it over there. Divide by x equals 10. There's your solution. Okay. Setup doesn't change. The mathematics involved in solving the equations does. We've talked about this a lot of times in here. On a 4-point question, this gets you 3 of them. Just got to get to the end. Okay, and you should be getting better and better and better at solving equations. All right, so our whole goal for today was to be able to solve 2 different types of problems. Triangle sum theorem. The sum of the interior angles of a triangle is always 180 degrees. We able to do those?
Yep.
The other part was to be able to use the remote interior angle theorem to solve. We good?
Yep.
Okay. Assignment